So these are the solutions to the Chapter 7 study team test. I'm going to try and be thorough in my explanations and assume that you're confused or you don't know things. So if you find that this is going too slow, kind of just skip forward to the questions that you need discussed. The first question, there's two parts, A and B. It says, are the triangles below congruent? If so, state the triangle congruence condition that justifies it. Later on, there's a problem that asks us to list all 5 triangle congruence conditions. And one of the things you'll notice is that all of them, every single one of them has to have information about side lengths. None of them just have angles only. So when you look at this, although it is true that the triangle angle sum theorem does force this angle, angle J, it forces this to be 95 degrees, and it also forces angle N. Over here on the other side, it forces this to be 29 degrees, right? That's still just information about the angles. So the problem with that is if it's just angles only, we don't know if the triangles are congruent or not. They certainly are similar, right? They have the same shape, but also they need to have the same size in order to be congruence. Congruence is a combination of both same shape and same size. So without information about the side lengths, we would have to say for this one, they're not necessarily congruent. And I say not necessarily because it could very well be that, LK and ON actually are the same length, but I don't know that. So I would say not necessarily congruent. So there's no congruent condition for there. The next one, however, clearly they're not drawn to scale. When you look at these angles, this angle down here, this is, I guess I could call this angle CBA, or CBD rather. Angle CBD is shown to be congruent to angle ABD, right, with those tick marks, but clearly the lower one is larger. So I think that's why they look like they're not congruent. But if those actually were the same size, and you combine that with these angles both being right angles, and you also combine it with the fact that they share this length down the middle, right? DB is congruent to itself. We would have to say that they are definitely fitting the angle, right? That's the right angles, and then the side that connects them, and then the angle. So this is the ASA congruence condition, and these triangles clearly meet that. And again, if this angle was actually the correct size, it would either shrink this one down, right, or it would make this one larger, and they would actually be congruent. So I would say they are congruent, yes. And why are they congruent? Because they meet the angle side angle condition. Let's jump to number 2. So at this point, there's so many different ways that we can tackle these. It's kind of difficult for me to pick, what's the best way. One of the things I like to do is to put things that have the same bases next to each other. And I also like to grab out any numerical parts that I can too. So when I look at this, this is just 2. It's not 2 to any power, and this is just 4. So if I combine those, 2 times 4 is 8. And then I'm going to write x to the negative second, and then I'm going to write times x to the positive fourth. So you can see I'm taking care of these factors, and these factors. Then I've got times y to the negative fourth, so these factors are taken care of, and then times y to the negative ninth, so those are taken care of. Now, because I have the same bases, I can combine a couple of these things, right? The x to the negative second and x to the fourth, I can combine as x to the second power. So I would write this as 8x to the second power. And then I end up getting y to the negative 13th power, right? Y to the negative 13th power. Now the instructions say that you can only write your answer with positive exponents. So this y to the negative 13, we need to change kind of its form. And the tool that I keep going back to is if I multiply this fraction times y to the positive 13th over y to the positive 13th, I don't change the value at all because I'm only multiplying by the number 1. In my numerator, when I multiply y to the negative 13th times y to the 13th, that equals y to the 0 power, which is equal to 1. So in my numerator, I'm left with 8x squared. And on my denominator, I have 13 factors of y, or y to the 13th power. So that's my answer for part A. Part B is awfully similar. One of the things that happens though is I do have a couple products that are being raised to a power, and there's a couple different ways I can deal with that. I think I might look inside of these parentheses first and try to simplify that, and then I'll raise that to the third. So if I'm looking at just inside those parentheses, that's a 2y to the negative second power. And if I want to get rid of the second power to the negative second power, I can again multiply by y squared over y squared. So this would make this equivalent. It's equivalent to 2 over y squared. So that's the thing that's in red. So what I have here is 2 over y squared, and I need to raise that to the third power. Well, I can multiply that out by itself, right? 2 over y cubed times 2 over y cubed times 2 over y cubed. And I can look at what I have, but it ends up being, 2 times 2 times 2, or 8 is in my numerator, over y to the 1, 2, 3, 4, 5, 6th power. So 8 over y to the 6th. So let's continue, right? So we've got this first chunk a little bit simplified. The next thing, you can see I've got this 8. I've got this 8x to the negative second power. Probably I just want to bring this part over, right? This y to the 7th. I'm just going to times y to the 7th. I like that how it is, so I'll just leave that there. But let's consider this 8x to the negative second power. So again, it's 8x to the negative second power. If I want to deal with that negative exponent, I'm going to multiply this by 8x to the positive second power over 8x to the positive second power. So if you look at my numerator now, this simply becomes 8x to the negative second power times 8x to the positive second power. That's 8x to the 0 power, which equals the number 1. So my numerator is a 1. My denominator becomes 8x squared. Well, if I multiply 8x times 8x, that ends up being, I guess I can write it out, 64 times x squared. So if you look at this, what I have here is I have 1 over 64x squared. A couple things I can do to clean this up. You can see I've got 7 factors of y in my numerator and 6 factors of y in the denominator. That ends up being just 1 factor of y in my numerator. So let me write this here. So I've got 8 and then just a y. And then in my denominator I've got 64x squared. And that's almost done, except 8 times 8 is 64. So if I think about that, I've got 8y over an 8 times an 8 times an x squared. So you can see there is a giant 1 locked up in this 8 over 8. So my final answer is going to be y divided by 8x squared. Y divided by 8 and then x and then squared. And I empathize. Probably some of you are feeling like I need some extra practice with that, Mr. Roberts. One of the best things I could suggest is downloading GeoGebra and just writing some problems like these on your own. And then you can always rely on it to basically do the right thing. So if I look at just this part right here, in fact, let's look at this together. I'll highlight in green. This part, it's 2y to the negative second and then raise that to the third power. Let me grab GeoGebra. Oops, where are you at? Here you are. And I've got it in CAS view. So this is, I can't remember how, CAS, Computer Algebraic System. So once CAS is on, I've got my cursor right here, and I'm actually using their little keyboard, their virtual keyboard. But I'm just going to enter open parentheses, and then I'll hit 2, and then y, and I want to raise that to a power of, and use that little up arrow. It's a shift, the number on your keyboard, or you can see it on their virtual keyboard. It's right here. So that's 2y to the power of, and then I'll just hit -2. I'll close my parentheses, and then I'll raise that part to the, so raise to the power of 3. So if I press enter on it, I want you to see that it exactly gets this to be where we had it, right? We had this becomes 8 over y to the positive 6 power. So you can practice a lot of these expressions just like this. In fact, if you were to type this entire problem in as it appears here, GeoGebra would basically resolve it so that there wouldn't be any negative exponents and it would completely simplify it. So really powerful thing to do. Assign yourself practice. This is a great tool because you can check your work immediately and make sure you're getting the correct answers. So it's something you have to kind of self-diagnose, decide I don't understand that, and then just make up some problems and test how they're going. Also, if you flip through the textbook and you look at problems like this as they have occurred, or look at previous tests, there's just a huge library of problems for you to go back and look at and review. And the more you do, the more comfortable you're going to feel with that entire process. There's one more problem on this page. It says Sandy is thinking of two numbers, and she knows two things about them. One of the things that she knows is that the sum of the two numbers is 22. So if I let my numbers be x and y, I can definitely say that this expression shows that the sum of the numbers is the number 22. And also the difference between the two numbers is 8. So here's the difference between them is the number 8. So if you look at that, the sum of the numbers is 22 and their difference is 8. This is a super simple system of equations to solve. It's all set up for elimination. As I combine these, the y variable eliminates, and I'm left with 2x equals 30. If I divide both sides by 2, we get one of the numbers has to be 15. And then the other number, it doesn't matter which equation I use, I'll use this top one, and I'm just going to plug in this value of x. So instead of x, I'm going to write 15, and then I write plus y, and then that equals 22. So y, this is all off screen, sorry, y would have to be 15 minus 22, which is exactly the number 7. So y is 7. So our two numbers are 15, that looks like a 16 perhaps, 15 and the number 7. Again, when you add those, you get 22, and those two numbers have a difference of 8.